Hello, good evening, everyone. Yes, good evening, guys. So hope my voice is clear to everyone. Is this clear? Is my voice clear to everyone? Okay, thank you, guys. So let me share my PPT. I think even my PPT also visible to you all. So once it is visible, please do type on chat box. It is visible. Is it visible? So we all set with all requirements, right? So voice is visible. But why the number of students are very less? So still we have 3 more minutes, right? So let everyone join, guys. So exactly at exactly at 5:50, I'm going to start the session. So how was weekend, guys? Nice. Okay, Tanya. You had any classes before my class? Okay, till 12:30. 2 classes. Then Sunday you have 3 classes. Sunday do you have 3 classes? Okay. Eight 30 to 12:30. Fine. Hi Jyoti, good evening. 8:20 to 10:20, 10:20 to 12:30. So there is no gap. Okay, good, Tanya. Thank you. Thank you for the information. So still we have 1 more minute. I'm going to start a session at exactly 5:50, guys. Okay, I got one more message. Let me check. What is that? Hi, sir. Is it possible? Can you please shift the class to Saturday? Saturday, 7:30 to 12:20, sir. So that you should ask operational team, please. Okay. You have to request to operational team. I said, can you please record the session along with transcript? Yes, it is on today. So with transcription, I'm recording. No need to worry. Abhinavan. Okay, guys. So now the exact time is 5:50. So this is the time to start our today's session. Hello, everyone. Welcome back. I'm excited to see you all again for our second session. Actually, this is not second session. So I'm covering the syllabus of session 1 in session 2. So last class we have started with what we have started, guys. Only introduction part we have started, right? So today, so I'm starting the exact syllabus. Okay. So now I would like to start today with a quote, guys. I have chosen this quote from Guinea Rometi. Okay. So he was the former CEO of IBM company. So what he has said, So he said data is the new natural resources. So it is just like we extract oil and other resources. So we need to extract value from data, and the systems we use to do that are what we here to talk about. Okay, guys, actually before we dive in, so let me ask you something, guys. So in your own words, what is a big data system? My question is, what is a big data system? I'm looking for your answers, guys. Don't worry about giving me a perfect definition. Okay, just tell me what comes to mind. So what do you think a big data system is? One second, guys. Yes, I got one response. So one response from one of my friend. So big data involves extremely large data set. Thank you. A system which can handle large amount of data and can perform ETL on data for further analysis. Good. The framework to store and process. Very good answer from Siva Chidanandaram. And Yash is saying big data system is the collection of the structured and unstructured data. It is not only collection of data. So along with that collection, we are going to process the data. Yes, very good answers I'm getting from each and everyone, guys. So working or analyzing huge data set using NoSQL. Not only by using NoSQL, Samanvita. Okay, and Sai Deepak is saying handling large amount is big data like ET, ETL, and ELT. Okay, combination of tool to process storage and analysis. Very good answer. So big data is very large data files. Okay, good answer. All right, guys. So let's try the definition of big data in different approach. Okay, let me take the example. Let me take one name, guys. So let me take Sai Deepak. Okay, so I just want to talk to Sai Deepak now. So Sai Deepak, can you tell me what is the hard drive capacity of your system? Sai Deepak, I'm talking to you. What is the hard disk capacity of your system? What is the storage capacity? I'm asking you about storage capacity of your laptop hard drive. So it is 1 TB. Okay, so Sai Deepak is saying, so his system capacity means capacity of his mobile memory is 1 TB, 1 terabyte. Great. Now, if I give you a what single file that will be what of size 1.5 terabyte. Okay, I have given you 1.5 terabyte of single file to save on your laptop. So what would happen, Sai Deepak? What would happen? Would it fit to your system? Would it fit to your systems, guys? No, right? And one more question, guys. Many of my friends typed huge amount of data. Correct? No? You people have typed at the time of what definition, huge amount of data. According to you, what do you mean by huge amount of data? According to you people, what do you mean by huge amount of data? Shall I call 1.5 TB as a huge amount of data? Just now I have given 1.5 TB of data to Sai Deepak, right? So is it called as big data, guys? Okay, so one of my friend is saying Yuvraj. So that should be in petabyte or even more than that. That is called as big data. Okay. So then 1.5 TB is not big data. Try to understand the analogy what I'm telling you guys. I asked Saideep to say is hard disk capacity. So he said his hard disk capacity was 1 TB. So now I have given 1.5 TB of data to store on his system. But it is not allowing 1.5 TB of data to store on Sai Deepak system. Is it not big data to Sai Deepak system, guys? Is it not big data to Sai Deepak system? Yes or no? I'm just asking you a question, guys. That's it. Is it big data? Guys, actually, for Sai Deepak laptop, the 1.5 TB of data is big data. Okay, guys, this is a simple, relatable example, but it perfectly illustrates the core problem that big data systems solve. How many of them will agree with my point, guys? Everyone, right? So everyone will agree with my point. Now you are all understanding, right? See, suppose, so we have 20 petabyte of data. Okay, so 20 petabyte of what? Hard disk capacity. 20.1 petabyte of data is big data for me. Okay, you take exabyte of data, yottabyte of data. So whatever it is. So once it is beyond the capacity of your system, means then it is called as big data. So hope everyone are understanding what exactly the definition of big data. Now let's scale this up to a real world scenario, guys. So think about a company like Amazon. So they have millions of customers, correct? No? And every single day, those customers are generating massive amounts of data. Okay, they are searching for products, adding item to their carts, and making purchases, writing reviews, so on and so forth. Guys, this is not a 1.5 TB file. So we are talking about petabytes and even exabytes of data every single day we are collecting. Okay, a traditional database or a single server simply cannot handle that volume and velocity of data. Okay, so trying to process all that information on a single machine would be like trying to store that 1.5 TB file on Sai Deepak laptop. Okay, so it is not just possible, guys. It is not just possible. So this is where big data system comes in. Okay, so they are designed to handle data that is too big, too fast, and too complex for traditional system. So according to me here, so the laptop system means the laptop of Sai Deepak is traditional system. So in that traditional system, the capacity was how much, guys? 1 TB. It is not possible to store on that traditional system. So that's why it is big data. And one more very, very important thing is the big data are distributed. I think every one of my friends are agreeing this point actually. So they are distributing. So meaning they use a network of many computers working together to process and store data. Okay, so we are going to spend the rest of our time together learning how these powerful systems are built and how they help companies like Amazon turn that raw data into valuable insights. So like personalized recommendations and fraud detections. Okay, so are you all ready to dive in, guys? Are you all ready to dive into the the big data concept? Can you all type RADY in chat box? Very big RADY in chat box once you all ready. Still, I have only 54 students, guys. 140 students admitted, but still I have less than 50%. I don't know why. Okay, so let's get started, guys. So, all right, everyone, we just talked about what big data systems are. Now, let's take a step back, guys. So, before we can have big data system, so what do we need first? So, what is the fundamental ingredient that fuels these systems? So, it's exactly, guys. So, first we have to understand the definition of data. Correct? Now, the definition of data is very, very important. So tell me what comes to your mind when I say the word data. What comes to your mind, guys? So what is data is according to you people? What is data is? I'm asking you what is data in general sense. Don't overthink about it, guys. Just share your initial thoughts. Anyone can share your thoughts actually. I'm getting so many answers. Good. Very good, guys. I'm getting so many answers. See, quickly I'm receiving the responses. This is showing your interest towards what today's session. Thank you all, guys. Excellent answers I'm getting, guys. So you have all touched upon some important aspect. So that is called as data, right? So in its simplest form, it is information. So many of my friends have given this answer actually. So it is nothing but an information, correct? No? Once again, guys, it is nothing but an information. So information means it is a collection of, let me write here, collection of facts, figures, observations, or measurements. Okay. And it can be anything from the numbers on a spreadsheet to the words in an email. Okay. The images on your phone actually, or even the clicks you make on a website. Everything is called as data. So each and everything is called as data. Now let's look at the what real world example. So continuing with our large online retailer like Amazon or Flipkart. So let's think about all the different kinds of data they collect every single day. Okay. So as you can see here, guys. So I think I have, I think I have put, definition here. Okay. So see, you can observe here. So this is the what entire topics I'm discussing in today's session. So here I have clearly mentioned. See here I've clearly mentioned. What is the definition, guys? Millions of transactions and browsing clicks per day. Look at here. Clicks per day. So they are not just collecting sales figure. So they are tracking. Correct? No, they are tracking millions of transactions and browsing clicks per day. So think about every single product page you visit, every item you add to your cart, every purchase made. So that is a massive stream of data being generated constantly. Correct? No? And look at here, guys. I have taken one more keyword here. What is that? Delivery tracking. Okay, what do you mean by delivery tracking, guys? So where is your order right now? So that information, the movement of every package is also called as data here. So not only these two, guys. So along with this, so we are going to consider reviews on multiple channels. Okay. So what are customers saying about the products? So this includes review on their websites, social medias, customer support, and so on and so forth. Okay. So these are all valuable textual data, right? These are all valuable textual data. And along with that, so we are going to say about support emails or logged calls actually. So when you reach out for help, so those interactions, the email you sent and the recording of your phone calls, also these are all called as data points, right? So this also comes under the data actually. And look at here guys, next I have taken ad click, browsing data. So what ads did you see guys? Did you click on them? What other products were you looking at before making a purchase? So this helps them understand your interest. Okay, and the list goes on guys. Not only this much, whatever I have listed, the list goes on. So as you can imagine, so there are countless other pieces of informations they gather. And the second point highlighted here is, look at here. So what I have mentioned here, so data is a what mix of everything. So data is not all in the same format, guys. So it is a mix of everything. Correct? No? See, I have taken few keywords here. It is a mix of metrics. What do you mean by metrics, guys? These are the numbers. So sales figures, okay, website traffic, delivery times, everything comes under metrics actually. And next, I have mentioned natural language text. So this is the point I have mentioned here. So this includes customers' reviews, support email, social media post. And yes, many times we have talked about what logs, right? So log file is it. So even logs, these are all the what records of system activity, like when someone logs in or when a server responds to the request, everything is comes in logs format actually. And events means what guys? Action that happen, like a product being added to a what wish list or a video being played. And video and images is also comes under data set guys. Data guys. See your product photos, or user uploaded content, even potentially security footage in their warehouses. So everything guys, each and everything is called as data. So when we talk about big data in the context of large organization, it is not just about volume of data. I'm not going to say only in the form of in the view of what volume of data. Although that certainly the major factor, but it is also about the variety of data what we are collecting and how quickly it is being generated. So variety of data also we are considering here. So along with that, we are considering velocity of data also, guys. So we'll delve deeper into these characteristics little later. Okay, but yes, guys, everything, every constraints is comes under data concept. But for now, does this give you a clear picture of kind of data we are talking about in the data-driven enterprises? Any question at this stage, guys? Let me check anybody is putting any questions on the. Once again, could you explain about delivery tracing? Delivery tracing means, see, you just imagine, okay, you have purchased an item in Amazon. Okay, there you are going to trace the delivery track, right? So from where it is started, so where it is now. So that is called as delivery tracing. Narayanan, have you understood? On what day it is, on what day we are receiving it? Okay. So great, guys. Now that we understand the what of the data. Okay, the what of the data. So let me show you one more slide here, guys. Look at here. So I'm moving forward. So we have to talk about what is data used for. What is data used for? So anyone can answer for this question, right? Okay. Guys, now we have established the what. Okay, what is data? So we know the kinds of data a company like Amazon collects. But let's be honest, collecting all this data is just a huge expense if you don't do anything with it. Correct? No? Simply you people are collecting data, but you're not doing anything with that means, then what is the use of collecting all this data, guys? Am I right or wrong, guys? So you are just storing informations in a digital warehouse. The real magic happens when you ask the question, what is this data used for? Correct, no? So this is where the value, see, I'm talking about one more keyword here. So this is where the value of a big data system truly shines. See, guys, actually in last slide, I've covered 3 V's. So I've covered 3 V's. So these are the 3 basic characteristics of big data actually. So along with that, I'm telling you about value. One more V I've added here, correct, no? So that is value actually. Guys, here I have mentioned few points. You just go through these points, guys. User profiling for better shopping experience. Okay, so have you ever noticed how Amazon seems to know exactly what you went before you even search for it? Yes or no? It will be having all the information about you people, right? So they recommend products that are yearly perfect for you. Correct? No. So this is not magic, guys. It is a direct result of analyzing your browse history, your past purchases, and what similar customers are buying. So this data allows them to create a detailed profile of you, the user, and tailor the entire shopping experience. Understanding my point, guys? And next we have operations efficiency metrics. Operations efficiency metrics. So how can a company like this manage its massive network of warehouses and delivery trucks? Okay, so by analyzing data on package locations, delivery times, and inventory levels, and they can optimize their operations. Okay, so they can figure out the most efficient routes for their trucks and predict when a warehouse might run low on product and make sure your package arrives on time actually. Correct, no? That is the operations efficiency metrics. And third one I have mentioned here, improves the customer support experience and support training. Guys, you just remember those support emails and logged calls we talked about. So by analyzing the common issues and the language used by both customers and support staff, they can identify pain points, automate responses to simple queries, and even train their support agents to be more effective. Correct, no? And what is the next point, guys? Next point is on demand forecasting. Okay, this is a huge one, guys. So this is a huge one, demand forecasting. Correct, no? So by looking at historical sales data, seasonal trends, and even what's happening in the news, so they can predict what product will be in high demand. So this allows them to stock up on those items in advance, so they don't run out when you want to buy them. Correct, no? So think about how they prepare for a major sale event like Black Friday or Diwali offer. So they are not guessing, guys. They are using your data. So based on that, so they are going to what, conduct that Black Friday or Diwali offer or January offer. Correct, no? And finally, we have one more, that is product marketing. Okay. See, this is the final one, guys. See, all this data helps them market products more effectively. So instead of what, sending the same generic email to millions of people, they can send targeted advertisements based on your interest and past behavior. So this makes their marketing campaign more successful and less annoying for us as customers. Guys, you can see here all that data we talked about in a previous slide is not just sitting there. So it is actively being used to drive every aspect of the business. Correct, no? That is what I have mentioned here. Okay, data is the only way to create competitive differentiators. So retain customers and ensure growth. Guys, what I would like to say here is in today's market, so everyone can sell a product online. Yes or no, guys? Even common layman can product their products on online actually. Yes or no, guys? But what makes a company like Amazon stand out? So it is their ability to use data to provide a better, more personalized and more efficient experience. So it is the reason customers keep coming back and it's their competitive edge. See, this is the bigger picture, guys. This is not a simple picture I'm talking about you guys. Okay, this is the bigger picture actually. The why behind big data is very big picture actually. So we are not just learning about some new technology, guys. Try to understand this. I'm not here to teach you only tools. So we are learning about the technology that is at the heart of how modern successful businesses operate. So hope everyone understood the why part of your big data analytics, big data system, sorry. So any question on how this data is being put to use, guys? Guys, actually we have covered the what and the why in our next session. Okay, so we'll start exploring how the tools and technologies that make all this possible. But before that, so let's take a quick question session now. So if you have any question, you can ask me now. Do you have any questions, guys? So till here, everything is clear. So what about my pace of teaching? Is it okay for you all? Am I going fast? Since I'm teaching, I'll be not knowing, guys. Once I'm going fast, anytime you can what? Stop me. My pace of teaching is okay for you all, right? Yeah, thank you, guys. Okay, thank you. Thank you, guys. Now we are jumping into the very next slide. Look at here. So what is the title I have put here, guys? Data volume growth. Guys, just now we have talked about what and why of big data. Correct? Now in previous slide, we have talked about what and why of big data. So we saw how a massive amount of data is collected and how it is used to drive business value. Now let's talk about the how much. See, now I'm talking about how much. Okay, I'm talking about how much, correct? No? So we used an example with what? Sai Deepak. So 1 TB hard drive. But let's look at the what bigger picture. So we are not just talking about megabytes or gigabytes anywhere, guys. Okay, so you look at the what picture here. So take a look at this chart, guys. This you just look at this chart. This is a visual representation of an exponential growth of data over a time. See, we have started from 2010 all the way at 2030. Okay, notice how the blue part. So this is the blue part I'm talking about. So which represents structured data. So grows, but the purple part. Okay, this is blue part. Sorry, this is blue part. So this is the purple part actually. Okay, what is this purple part indicating, guys? This purple part is indicating unstructured data. Look at here. So these are all structured data. So here the growth is very less. But see, look at the growth of unstructured data. Okay, guys, structured data is the kind of data that fits neatly into a database. Correct? No? That you all know. And also in the upcoming slide, I'm going to give you more on that. Like your names in the customer list, or numbers in our sales report. So everything comes under structured data. But what about this unstructured data, guys? Unstructured data is everything else. You take images, you take videos, emails, social media post, website. Okay, the kind of data that does not have a predefined format is called as unstructured data. And you can see here, that's where most of the growth is happening, guys. By 2030, so we are projected to be what, dealing with 78 yottabytes of data. So nobody was talking about yottabyte actually in discussion what forum. Guys, look at here, 78 yottabytes of data. Now, what does a yottabyte even mean? It is hard to visualize, guys. So let's look at what some real world examples to put these numbers into perspective. So look at your right hand side. I have taken few examples. So Facebook, over 500 plus TB per day of comments, images, videos, etc. Guys, this is per day. I'm talking about per day. What is the capacity of Sai Deepak? So in 2 days, Sai Deepak system will what, fully what, filled with comments, images and videos of Facebook actually. So think about every person you know who is on Facebook and all the things they post. Everything is comes in this 500 GB, guys, 500 TB, guys. Okay, so now multiply that by billions of users. So that's how you get 500 terabytes per day, guys. And next one, look at here. Next, I have taken the example of New York Stock Exchange. Guys, they generate 1 terabyte of data per day. Data, this data is a trading data per day. Every single stock trade, every bid, every ask. So it is all logged. And this is data that has to be what, processed and analyzed in a near real time actually. Because in the stock market, every second counts. And one more example I've taken in third bullet point, that is a jet engine. Okay, so this one is fascinating. A single jet engine can generate 20 terabytes of data per hour from its sensors and locks. You know, right? In any of the jet, so we have used plenty of what, sensors. All sensors are going to what, generate data. Okay, generate some logs. Guys, just one engine. This data is crucial for monitoring its performance, predicting when it might need maintenance and ensuring safety. So these are all not isolated examples, guys. The data is growing at an incredible pace. And this growth is driven by social media, IoT devices, sensors, e-commerce, you name it, guys, whatever you want. So when we talk about the concept of big data, so we are not just talking about big numbers. So we are talking about a scale of data that completely breaks traditional systems. Okay, you can just open an Excel sheet for 500 terabytes. You cannot just store 20 terabytes of data per hour on a single server. So hope everyone will agree with my point. So this is the core problem. So we are going to solve with the tools and concept. So we'll be what, learning in this course actually. But I am not going to take petabytes of data or exabytes of data, guys. So we are going to take only piece of data. But see, I'm telling you, by using the tools what we are discussing, so we can what, achieve all these things. So hope you all understood what exactly the volume of data is. So if you have any question on this statistics, you can ask me, guys. If you have any question on this statistics, you can ask me now. Now I have a question to you all, guys. Does this put the big data into a better perspective for you all? Huh? So what is the difference between structured data? I will tell you. Wait for a while. Okay. See, structured data, I've told you, right? So there is a format for structured data, but there is no particular format for unstructured data. So that each and everything we will discuss one by one. No need to worry now. Okay, so now I'm moving forward, guys. See, look at here, guys. So I was talking about volume, right? See, just saw the mind-boggling scale of data growth. So now let's circle back to something we touched upon earlier. So we have talked about variety, right? Already we have talked about variety. So now I'm talking about variety of data. Okay. So look at here, guys. It visually summarizes so what we are being discussing, but in a more comprehensive way, guys. The term big data is not just about a single massive stream of information. So it is about a convergence of many different types of data. So coming from countless resources. So all flowing towards a central point actually, or repository point actually. Okay, so let's break down some of these sources. So I have listed only a few sources, guys. Okay, I have not listed everything. See, on the far left, you see an image of plane. Correct, no? So this is the plane I have taken here. So that represent the sensor data we just talked about. With a jet engine generating 20 terabytes of data an hour. But it is not just jet engine, guys. So think about all the sensors in your car, your phone, or even in smart cities. So they are constantly generating data about locations, temperature, air quality, so on and so forth. Okay, so next to that, so we have log data. Look at here. So this is, I'm talking about log data. So here also I mentioned sensor data, and this is log data. I'm talking about log data. So every time you visit a website, so log into an application or your computers perform an action, a log file is created. Correct, no? So these logs are detailed record of what happened and when. And they are a treasure trove for understanding systems behavior and user patterns. And next to that, we have web data, guys. So next to that, we have web data. So this includes all the informations you can find on the internet. Okay, from public website to the data generated by your browser activity. So this is different from social media. So which is specialized type of web data. Okay, so speaking of which, so we have what social media. So represented by the what Facebook logo. So this is a massive source of unstructured data. So there I can get post, images, comments, likes, correct, no? So on and so forth. So companies analyze this data to understand public sentiment, track brand mentions actually, and identify the trends. Okay, and also we have one more, guys, that is called as media data. Okay, so which includes all the images, all the videos, audio files that exist in the world. And don't forget docs, guys. So even your docs, see document file, I'm talking about document file, all the documents, your emails, presentation, and report that are created and stored every day within organizations is comes under docs data actually. And finally, we have archives and other historical data that company have been collecting for years. Okay, this might be older customer records, financial reports, so research data that is now being digitalized and integrated into modern big data systems. And then, guys, in the top right, we have a picture of what? NYSE. I have already told you, right? New York stock market data actually. So which represents the constant stream of financial data we mentioned. Guys, the key takeaway from this complete images is that big data systems need to be incredibly flexible. So they have to be able to ingest and process all of these different kinds of data. So whether it is structured data, unstructured data, or semi-structured data. So from all these devices, diverse sources, often at the same time. So this variety is one of the biggest challenges, but also one of the biggest opportunities of working with big data. And it is what allows us to paint a complete picture of business and its customers, leading to more powerful insights. Okay, so then when we talk about big data systems, we are not just talking about a single tool. We are talking about an entire ecosystem of tools, technologies designed to handle this complexity. So we are going to start exploring these tools very soon, guys. No need to worry about that. So does this diagram make sense to everyone? Does this diagram make sense to everyone, guys? Otherwise, you have something in your mind, means you have any other resources, means you can put on the chat box. Other than this, so I've covered maximum. So other than this, you have anything in your mind, means you can put on the chat box. So shall we move forward? Okay. Once again, guys, you give me 1 minute of time. So sorry for the inconvenience, guys. I was switching on fan. Okay, it is too hot. Okay, now we are moving forward and we are talking about next slide. So look at the next slide, guys. So here I'm talking about classifications of data. Guys, actually under this classification, brings us to the fundamental concept of big data. So we have three different types of data here, big data here. First one is called as structured data. So one of my friend was asking questions on structured data. So I'm going to explain you what exactly the meaning of structured data now. And next to that, we have the second type that is called as semi-structured data. So that I'm going to explain you in the next slide. And third one, we have unstructured data. So these are the three different main types of big data system. So let us start with the very first one, that is called as structured data. Okay, so guys, structured data is the kind of data that has a well-defined format. Okay, so think of your spreadsheet. So let me ask you one question, guys. So how many of them are working on Excel sheet? So anybody is using Excel sheet? So in your daily use or in your company? If anybody is using Excel sheet in everyday process, can you type all, guys? Now, instead of typing yes, you type spreadsheet or Excel sheet, guys. Or short form of that, Excel sheet, ES. Okay, Google Sheets are using by many people. Guys, actually, can you tell me a few words about Excel? So how we are going to store data there in Excel? So your worksheet or Excel sheet is organized into tables, right? With rows and columns. Correct, no? We know exactly what each piece of information is and where it belongs to. Am I right or wrong, guys? And how many of them are using SQL? How many of them are working with SQL? If you are working with SQL, you type SQL. So instead of typing yes, you type SQL. See, look at here, guys. Many of my friends are using SQL. So how we are going to store data in a SQL, guys? The same way, column and rows we are going to use to store the data there, right? Correct? No. See, for example, a customer record might have columns for customer ID, first name, last name, email address. See, every record follows the same structure, right? See, the main point what I would like to explain you here is the key point in all what Excel and SQL, it will be having fixed schema. Okay, so this kind of data is very easy to search and very easy to sort and very easy to analyze using traditional tools actually. Guys, by using SQL, you can analyze data very easily, guys. Okay, the example of the NYSE, New York Stock Market Exchange, the trading data we discussed is perfect example of structured data. So it is all numbers, guys, and well defined actually, very well defined. So hope everyone understood what exactly meant by structured data. So is this clear to everyone? So if you have any questions on structured data, you can ask me now. So it is very easy, guys. Very easy to understand what is the exact definition of structured data. And next, look at here. I have mentioned one more here. That is semi-structured data. So here I have explained about structured data. So now we are talking about semi-structured data. Okay, so this is the middle ground. Usually I'm going to call it as middle ground. Semi-structured data has some organizational properties, but it does not fit into the rigid fixed schema of traditional databases. Okay, the best example for this is XML, JSON. So all these files comes under semi-structured data. Okay, so they use tags, guys. Usually, you know, right? So XMLs are, your JSON are going to use tags. Okay, sometimes these are all going to use a key value pair to organize your data. So which gives some structure to the data set, but that structure can be flexible here. So it will be not having fixed scheme here. A record for one person might have an extra field that another record structure data efficiently. Correct? No? Another data that will be not having the data actually. See, traditional databases have some support for this, guys. But to handle large volume of semi-structured data efficiently, so we need a new kind of databases. So what kind of databases we are going to use to handle this semi-structured data? So we are going to use NoSQL databases. So which we will get into later in this course. No need to worry. I have a separate session on NoSQL. I'm going to explain you that. So this is where a lot of modern web data lives. Guys, the final one, I'm talking about unstructured data. Unstructured data. So this is not structured. This is not semi-structured. So this is the biggest and the fastest growing category. Remember this. Unstructured data has no predefined format or organizations. You think about a bulk of data we have been talking about. So we have talked about social media post, right? We have talked about image, videos, and support emails, PDF documents. So there is no row and column for sentiment and main subject in a picture. This data is the most difficult to process, and this data is most difficult to analyze by using traditional methods. Remember this. The insights are hidden within the content itself. And we need advanced techniques like text analysis, image recognition, and machine learning to extract that value. Remember the Facebook example, guys. So most of that 500 plus TB of data per day is unstructured. Most of the data is unstructured, guys. So the challenge of big data is not just about the volume, but also about the incredible variety. And the fact that a large portions of its data is unstructured. So we need system that can handle all three of these data types often at the same time, because A real world scenario often involves a combination of all three. Say, for example, a customer review, it is unstructured text. Correct? No? Might be what linked to your customer ID and product data. So customer ID and product ID both are belongs to what? Structured data actually. So it will be having mixture of both. So these are the three different types of data types, guys, big data types. So some of my friend was asking question on this. Some of my friend was asking question on this. Now you have understood what exactly the difference between structured data, unstructured data, and semi-structured data. Is there any question? Is there any question, guys? I don't know the name, but somebody asked this question. I'm not getting any response. Okay, guys, next 3 slides again, I'm explaining on the same thing, guys. I don't want to repeat the same definition again, but a few points I have to highlight here. I'm going to highlight with few points. See, look at here. Here I'm purely talking about structured data. Okay, so deeperly we are diving into the concept of what structured data here. Okay, so this is probably the most familiar to all of you, and it is the foundation of most traditional database system. Okay, so here for that we are going to use RDBMS actually. Correct? No, we are going to use RDBMS. So as we discussed, structured data is all about what? Organizations. Okay, so the key characteristic is that so it is transformed and stored according to predefined schema. So that is the point I have explained you in the very first point. Okay, so take a look at the what table I have taken here. Table employee. Okay, so we define the columns. What are the columns we have taken here? Columns we have taken as employee ID, name, designation, salary, and department code. So these are all columns, guys. And we specify what type of data each column will hold. So here we have mentioned integer, varchar, integer, and again here integer. Okay, so this is a schema. So what is the column name and what type of data we are storing? This is called as a schema. Every single record we add to this table must conform to this exact structure. Okay, so because of this rigid structure, structured data is traditionally stored in RDBMS concept, Relational Database Management System. Okay, you might have heard about MySQL. So MySQL is the best example for this RDBMS. And maybe you have heard about Oracle. Maybe you have heard about SQL Server, SQL Server. So all these are belongs to this RDBMS group. With RDBMS, we can perform CRUD operations. So what is CRUD means, guys? Can anyone tell me what is CRUD operations means? If you have an idea. So many of them told, right, worked on SQL. What do you mean by CRUD? Huh? Yes, it is comes under semi-structured data. Key value pair is comes under semi-structured data. So create, read, update, and delete. Correct? No? So this is how we manage individual records in our databases. So we can add a new employee. We can read an existing employee details, and we can update their salary. We can update their name. We can update whatever we want, and we can delete their record if they leave the company. So I can perform all 4 operations in RDBMS. Okay, and next we have ACID semantics. So maybe you have heard about ACID semantics also. Atomicity, consistency, isolation, durability. So what do you mean by atomicity? So let me listen from your mouth only, guys. What do you mean by atomicity? What do you mean by atomicity, guys? Hmm? So those who are worked in SQL. Unique, okay. No, it is not volume of data. Which one you're talking about? Atomicity is not a volume of data. Single indivisible unit of work is called as atomicity. Yes, your answer is perfectly correct. With respect to RDBMS, so the meaning of this is a transaction is all or nothing. So either all of the operations in a transactions are completed or none of them are. Okay, there is no in between, guys. That is called as atomicity. Yeah, here my friends are typing now. And what about consistency? What do you mean by consistency? Hmm? What about consistency? Yes, you know the answer of durability means you can type, guys, not an issue. A transaction moves a database from one valid state to the another valid state. Very good. So it is going to ensure that the database remains in a valid state after a transaction. That is called as consistency. And next we have isolation. What is isolation means? Isolation guarantees that concurrent transaction do not interfere with each other. So it is like having your own private workspace while working in a what shared office. That is called as isolation. Correct? No? Yes, of course, correct. So this answer is perfectly correct. Isolation. And what about durability? So once a transaction is committed, so it will be remain so actually. So even in an event of what system failure, the data will be what remain actually. So this is called as acid property, guys. So these are incredibly important for things like banking transactions. Correct? No, in banking transaction, so these are all very, very important. Acid means acid semantics will play what crucial role. Okay, and look at here, guys. The system also offers fine grained security and also authorization. Of course, everyone has to be what? Has to what? Agree with this point actually. You can grant specific users permissions to read, write, delete data from your specific table. And also you are ensuring data is secure and accessed only by authorized personnel. That is called as security and authorization. Correct? No? And what is the next point? Knows techniques on scaling RDBMS. More on this later. Okay, so these 2 points you can understand by yourself, guys. So last 2 points you can understand by yourself. Okay, typically used by systems of records. Example, OLTP, online transaction protocol system with a strong consistency requirement and also read or write workloads. Guys, this everything is comes under structured data concept. Okay, so now I'm moving into the unstructured data. Now why it is not working? Okay, so this is semi-structured data. Okay, let me start with the semi-structured data. So you all can observe here. So now we are talking about purely on semi-structured data. Okay, so this is where things start to get a bit more interesting and more aligned with the modern web. Okay, the first key difference. So here is that there is no explicit separation of data and schema. So this is the very first point you have to understand. Once again, guys. Okay, no explicit data and schema separation. Guys, in structured data, the table schema is defined first and then you add the data. Correct? No? So here the schema is often embedded within the data itself. Understanding the difference. So between structured and also semi-structured. And look at this example. So this is the best example for JSON. So this is the best example for JSON. So what do you mean by JSON, guys? Can anyone tell me? So anybody know the full form of JSON? What do you mean by JSON, guys? JavaScript object notation, correct? No. Okay, so you can see the data and labels here. Yes, very good answers. Okay, you can see the data here. So we have title, type, description, image, weight, expiry, price, average rating, reviews. Correct? No? So what are these guys? What are these actually? So these are all called as key. So these are all called as keys. Correct? No? So what are the keys we have here? See, whatever we have put inside double quote. Since it is string, we have put everything inside the double quote. So these are all called as keys, right? And so look at here. Next to that, we have some value here. So this is called as values. So here we have used key values pair. In JSON, we have used key values pair. Correct? No? Are you all getting my point, guys? And now look at the definition I have given here. See, the next product in the database might have the key for calories. Okay. And it can have for ingredients that this product does have. So this flexibility means that semi-structured data models real life situations better. Because not every item or event has the exact same attributes. It's much easier to add new attributes on the fly without having to change the entire schema for the old table. There is no rules, guys. So here I have used 10 keys means it is not must every time I have to use 10 keys. I can add, I can delete. So I can do whatever I want. That is the advantage of using this semi-structured data. The most common format. So we have used in XML, we have used in JSON format. So XML is a bit older and more verbose, but still widely used. Okay, JSON has become the dominant format for web applications and API because so it is lightweight and also easy for both humans and machines to read. So because of that reason, most of the people are using JSON format nowadays. Okay, so because of this flexibility, so what I would like to say is the traditional RDBMS that rely on a fixed schema struggle to manage this data efficiently. This is why we need a new kind of databases. That is, we are going to call it as NoSQL. So we are going to start it with what? NoSQL databases. So which are designed for this kind of data, guys. Okay, these databases often have flexible ACID properties. So particularly with consistency, particularly with C. So we have what? Flexibility here. So they might offer what's called eventually consistency. So which means the meaning of eventually consistency means. So here I have mentioned. Okay, consistency. Eventually consistency means. So if you make a change, so it might take a moment to what? Propagate across all the replicas in the distributed system. But it will eventually becomes consistent also. Remember this. Okay, so this is the trade-off for better performance and scalability, especially in distributed environment. Guys, what you have to understand here is semi-structured data is typically used by what we call system of engagement. So next point I have mentioned here, system of engagement. Think about social media. So where a user profile can have what? Varying number of friends, posts and details. So the structure is there, correct? No, but it is not as rigid as a what bank account record. So this is about capturing and analyzing user interactions and engagement, where flexibility is more important than strict real-time consistency. So this is about semi-structured data. If you have any question on semi-structured data, you can ask me, guys. Yes, it is lightweight, correct. If you have any questions on semi-structured data, you can ask me, guys. So next I'm moving on to the third type, actually, third category, that is called as unstructured data. Is there any question on semi-structured data? So hope you all understood, right? What exactly mean by semi-structured data? What is ACID property? Just now I explained you, Anup. I asked from you people only, correct? No? Anup, have you joined now? Have you joined late? Arup Jyoti. Then, so last I have explained you about all ACID property, right? Atomicity, consistency, isolation and durability. Yeah, the same thing. Okay. So now we are jumping into the next one, guys. That is called as unstructured data. Look at here. Unstructured data, I've taken unstructured data 1, unstructured data 2, and unstructured data. Okay, only 2, not 1, 2, 3. So it is only 2 actually. Guys, this is in many ways the most real life data we encounter. So think about all the information that does not fit neatly into a predefined table or flexible JSON file. Okay, the examples like video, voice, text, emails, charts, comments, reviews, and blogs, so on and so forth. Okay, so videos means you know, right? So from security cameras and user uploads, you can get videos. Voice, you can get from customer service calls. Text, you can get from emails, charts, comments, reviews, and blogs. And images at the end. So images you can get from the social media, product catalog, everything. So all these data will never ever fit to the structured format. This is the data that humans can easily understand. But for traditional computer system, it is just a blob of bytes. A computer looking at a video file does not see a person talking. It sees a sequence of numbers. Correct? No. So how do we make sense of this, guys? See here in slide, it is mentioned. There is some structure that is typically extracted from the data depending on the use case. Okay, you just take at a look at this face diagram, guys. So this is the classic example of face recognition. Correct? No. So the original data is an unstructured image, but to make it useful, a big data system using advanced algorithm extracts a structure from it actually. So it identifies key points on the face like eyes, okay, nose, and mouth. Okay, and maps them out actually. So it's essentially created a structured numerical representation of the face from an unstructured source. Okay, this same principle applies to all kinds of unstructured data. So we can perform image adjustment at pixel structure level. And we can adjust face recognitions from the video. Correct? No, just like the image, guys, the system processes a video frame by frame to identify and track the faces. And third one, tagging of features extracted in image or videos. And finally, annotations of the text. So think about sentiment analysis. We take an unstructured customer review and extract a structured tag like positive, negative, neutral, so many things. Correct? No? That is comes under annotations of text. Guys, the purpose is to take this raw unstructured data and apply a powerful computations to it to extract meaningful structured information. The challenge is that this requires immense processing power. So as you can essentially building the schema on the fly. Okay, for every piece of data. So this is why we need distributed scalable system, because a single machine cannot handle sheer volume of this kind of data, and processing requires to extract and value from it actually. Guys, what I would like to say now is unstructured data is the final frontier of big data. So it is where we get the most unique and valuable insights, but it is also require the most sophisticated tools and techniques. Remember this. So if you have any question on 3 categories, you can ask me, guys. I hope with example, you all understood what exactly mean by structured data, unstructured data, and also semi-structured data. So if you have any question on this, you can ask me. I will not go to next slide, guys. Next slide, again, I'm explaining you on unstructured data. So once you have complete idea on unstructured data, I will not go with the second slide actually. Is this clear? But I can ask you one question, guys. So what can we actually do with unstructured data? So what can we actually do with unstructured data? Can anyone answer? See, I'm repeating the question, guys. I have repeated the question, right? What is the answer? See, answer to this question is where the real power of big data analytics comes into play. Correct? No? We use variety of techniques to extract value from this chaotic data. Exactly correct. You people are answering correctly. So that is what I have explained in the next slide, guys. So I have explained you about data mining concept here. So what we are going to mine here? So we are going to mine at the end with a what? Valuable insights. Correct? No? And maybe for that we are going to use regression concept, and we are going to use collaborative filtering concept, so on and so forth. And we have one more, that is NLP, natural language processing. So this is the field of AI and linguistic that focuses on enabling computers to understand, interpret, and generate human languages. And we are talk more about text analysis, sentiment analysis, and noisy text analytics, everything, guys. Okay, so this is the outcome of unstructured data. Okay, so as I'm explaining you here, the value of unstructured data is immense. So it is the key to understanding customer behavior, making accurate predictions, and building intelligent systems. So, but to unlock this value, we need to move beyond traditional techniques and embrace these advanced methods. Guys, this wrap up our discussions on the 3 types of data. This is a crucial foundation for the rest of our course, guys. Okay, so in future, we'll be talking more about structured data, unstructured data, and also semi-structured data. So hope the each and every concept is crystal clear to everyone. Is this clear? So if you have any question, any final question on these 3 categories, you can ask me, guys. Okay. Thank you all, guys. Next, look at here. So define big data. So now, can anyone give me the definition of big data by looking at this diagram? So this definition already I've given you, right? So I don't want to explain again the 3 V's of big data. So volume, velocity, variety, all 3 concepts already I've explained you. So by using this, you can define the definition of big data. Okay, guys, let me skip on this. Okay, now we are moving into the next diagrammatic representation. What is this, guys? What exactly this slide is explaining? So this is also not required, guys. It is a traditional RDBMS is good enough. That is not required. So now I'm jumping into next slide. This is very, very important slide. So here, guys, actually till now we have spent a good amount of time talking about different types of data. Now let's start talking about the engineering sides of things. Okay, so how do we actually build systems that can handle all this data? Okay, the first concept we need to understand is scaling concept. Okay, try to understand this, guys. So we have to discuss about what scaling concept. So let's imagine a common problem in data-driven enterprise. So think back to our example of the online retailer, their website, portal. These are all very popular, right? With a lot of users visiting concurrently. Correct, no? Look at here, I have mentioned many users are concurrently visiting the pages of portals. Hundreds of thousands of people are all browse at the same time, guys. That is the point I would like to explaining you here. And every time a page is visited, database needs to be updated to keep track of this visit. Am I right or wrong, guys? See, we need to keep a record of these visits to track user behavior, website traffic, so on and so forth. That is the second one actually. And the third one, database write is heavy operations. Database write is very heavy operations here, correct? No. So writing to a database takes time. Okay, it involves finding the right location, locking the data, and ensuring ACID properties. So when you have a massive number of users all trying to write to the database at the exact same time. So what it will create, guys? So it will create a traffic jam. Correct? No? And finally, I'm explaining you on database write is now a bottleneck. The database becomes the slowest part of the system. Everyone will agree with my point, guys. This is the slowest part of the system. The web server is ready to handle more requests, but it is stuck waiting for the database to catch up. So this can cause website to slow down or even crash. Now I can ask you a questions, guys. So how do we solve this problem? So how do we scale our system to handle this massive concurrent write load? Guys, the solution is to introduce an intermediate layer. So we are introducing an intermediate layer here. So use an intermediate queue between the web server and the databases. Look at here. So this is the web server and these are all databases. So in between that, so we are introducing intermediate queue. So this is the queue we are using here. Guys, instead of web server trying to write directly to the database for every single click, it simply sends a message to a queue. So think of queue is like a waiting line, guys. Okay, and queue will hold messages. Look at here. I have written here. Queue will hold messages here. The unique, see, the queue can handle a massive number of messages almost instantly. The web server sends the messages and can immediately move on to the serving the next user. And the messages will not be lost. The queue is reliable system, correct? No, I think everyone will agree with this. I think you have learned queue data structure. Same thing I'm explaining you here. So it holds the messages until the database is ready to process them. A separate process, perhaps in the background, can then read these messages from the queue and write them to the databases at a controlled, steady pace. Look at the diagram. This diagram is giving complete picture. So we have our users with their laptop. So these are the three users. Okay. And so we all sending request to the web server. So instead of web server talking directly to the database, it sends messages to the queue. Okay. The database now talks to the queue. This database is talking to the queue now. The queue acts as a buffer, smoothing out the traffic spikes. The web server can handle a burst of thousands of requests in a few seconds, send thousands of messages to the queue and then move on. The database, meanwhile, can process these messages at its own pace without getting overwhelmed. So this is a fundamental pattern in building scalable distributed system. So this your understanding means, then definitely I will tell you guys, in future you can build your own distributed system. So we are decoupling the front end applications from the back end data store. So this allows both parts of the system to scale independently. Guys, you can add more web servers to handle more users, guys. And you can add more processes to read from queue and write to the databases. Understanding? So why we have to add in between? This concept of queue is cornerstone of big data architecture. Okay, we will explore this later, guys. But this is the basic thing you have to understand. So when you are going to start with big data systems. Okay. And next slide, what I'm trying to explaining you here. See, look at here. Guys, just now I have explained you, or I have introduced a queue to handle their write bottleneck. That helped a lot, right? But what happens when our applications gets even more popular? Think about it. So when it is get even more popular, what if the queue is now constantly full? Once this queue is constantly full means what you are going to do, guys? And our single database just cannot keep up with processing all these messages, no matter how quickly it pulls them from the queue, guys. Correct? No. See, in this situation, guys, look at here. The application is too popular. You just imagine the application is too popular. Our online portal is massive hit. Is having what massive hits. Millions of users are using this portal in a what given time and generating enormous amounts of data. And maintaining the what page view count is becoming difficult even with the queue. Guys, our single database, even with the what queue feeding it, so is still bottleneck. Correct? Now the volume of data has simply outgrown its capacity to store and process it all. So this is the classic problem, another classic problem in big data analytics. So when a single machine cannot handle the load, the only solution is to use multiple machines. See, look at here. We have started using 3 different databases here. 1, 2, 3 databases. Correct? No? Are you getting my point, guys? So we have to use the word multiple machines. But how do we do that with a databases? So you cannot just copy the database and expect it to work, right? You need different approach here. The solutions to this problem is mentioned here. Look at it. So what we have to do, data is divided into partitions, so which are hosted on multiple machines. Okay, that is called as data sharding. I will explain you this data sharding when I'm going to teach you NoSQL concept. So we are distributing data in a what sharding methodology, and we are going to host the data on multiple machines. That is the first thing we are going to do, guys. And database writes are parallelized. So whatever the process we are doing, the database writes, so everything is parallelized here because we are using 3 different systems, guys. And see, by this, what I can do, guys, scalability is obviously increased, right? By adding more machines and more partitions, we can scale our system almost horizontally to handle any amount of data. So this is the core principle of big data system, guys, distributing the workload across many computers. And along with this, finally, what I would like to say here is scalability is increased. Along with that, complexity is also increased because I have to handle many systems. I have to what go with many systems. Correct? No, you just look at the diagram given here. So we have what? Multiple databases here. Okay. And also, guys, this final point I have explained, right? Complexity increases. Guys, splitting a database is not a simple task. So how do you decide which data goes where? What happens if one of the what machine fails? And how do you ensure data consistency across multiple machines? See, these are all the what complex questions that we need to address. That's why I mentioned complexity increasing. This complexity is the trade-off for the immense scalability we gain here. So this concept of partitioning and distributing data across multiple machines is absolutely fundamental to big data concept. Try to remember this. This is very, very important concept. I'm taking 3 stars here. Okay, so this is how we move from a single machine mindset to the distributed system mindset. So if you have any question on this, you can ask me, guys. Now we are all understanding, right? So now we are all understanding, right? See, one by one, I'm teaching you the what? I'm teaching you the complexity, challenges with respect to your big data concept. Okay, you have to keep everything in your mind, guys. So then only you will understand. So why and how we are going to handle big data. Yeah, shard means partition. Of course, yes. And can anyone tell me what are the issues with RDBMS? What are the issues with RDBMS, guys? Can you all list one by one. I have 61 students, guys. So everyone are giving what one issues means you can list 61 issues, or else at least 4 to 5 issues is enough for me actually. I am not looking for no Oracle. How come it is issues? Issues. See, I'm asking you issues with RDBMS. Okay. You just imagine, guys. I just talked about sharding, right? Okay. So with too many shards, some disk is bound to fail. Correct? No. In the case of what RDBMS. Definitely, Narayanan. I will give you scenario-based question in your examination. So there you have to think and explain to me actually. Okay, so next slide, I'm explaining you the same thing, guys. So issues with RDBMS. So I'm not going to explain you this. So after completion of my class, you go with each issues. Okay. So 2 slides we have given here. You just go with all the explanation I have given in these slides. And one more slide, actually 3 slides we have taken to explain each and every concept. Can you all go with the issues with RDBMS, guys, by yourself? Because I've explained too much concept to understand RDBMS concept and also big data concept. Now it is a time, and also content I'm giving you guys. Now it is a time to understand the issues with RDBMS. Everything I've explained, you. So how does the applications knows which partitions to write on to? That I will explain you later, Priyanka. You have to wait for a while. See, I'm telling you the challenges. Priyanka, you try to understand. See, previously we started using traditional systems. Okay, that is called as RDBMS. So now we are moving towards what? Big data concept. In big data concept, we are looking for few challenges. I'm telling you few challenges. So solution to that each challenges we will address throughout our sessions. So you have to wait for a while. So now only I'm explaining you all means you will not in a position to what understand it. I will explain you, no need to worry, Priyanka. Yes, Gautam. For your question also, you'll get answers in the upcoming sessions. See, this is what I'm looking from you people, guys. So this is what I'm looking from you people. Okay, you have to what? Come out with questions. So then only every means after completion of what each class, I'm going to what? Fill your dots. So how do we decide between whether to increase compute and have a single DB versus have multiple smaller shards? Guys, once the size, see, just now I've told you, right? Suppose the number of systems are increasing here in this diagram. So here the number of systems are increasing and the request is more. So request is more than your queue capacity is, then what you're going to do, guys? See, you just imagine. So previously I had 10 requests here. So instead of 10 requests, so 10 request was handling by single database. So previously we had 10 requests. Now this single database is handling 10 requests. Now the request size is increased. You just imagine the request size is 100. So is it possible to handle 100 requests by single database? No, right? So on that time, what we have to do, guys, we have to increase the number of databases. Okay, so this is called as partitions. Okay, usually, yes, you can think it as like, think like this also, guys. You can take a what single database and then you can divide your data. Otherwise, you can take 3 different databases and then you can divide your data. So anything is okay. Okay, but usually we are not going to use the entire database at once to what define on databases, right? So store your database, write your databases, correct? No? Shardul. So hope you have understood. So till here everything is clear, guys. So can you all go with issues with RDBMS? Okay, yes, guys. Till now we have done with why do modern enterprise need to work with data and what is big data and data classification scaling RDBMS. So we have covered first three topics. Okay, now we are jumping into next two topics. That is what is big data system. So we are talking about characteristics and also we are talking about design challenges. So in upcoming slide, we are discussing these things, guys. Okay, so let us start with the very first one. That is called as characteristics of big data. Guys, already I have covered this concept also in the previous session, but still I'm explaining you guys. Guys, you all know. So we have spent the entire session laying the groundwork. So we have seen the what shear volume, velocity, variety of data. So we have seen how traditional systems buckle under the pressure. Okay, now let's talk about the solution. So what are the key characteristics of big data system? So what are the fundamentally designed to do? So all these questions we have to answer, guys. So now let's highlight some of the core principles. So what is mentioned here in very first bullet point, you just read it. The application does not need to bother about common issues like sharding, replication. So this is the most important point, guys. So this is the most important point. So we just spent a good amount of time talking about the pain of manually sharding and replicating on RDBMS. Okay, so but big data systems are built to handle this automatically. So one of my friend was asking this question. Okay, so see, we have developed or invented big data system to overcome this problem. So here we are not going to do any manual sharding or we are not going to do any manual replications like your RDBMS. Okay, so big data systems are built to handle this automatically. The developer's focus is on the what? Application logic, that's it. So no need to worry about this hardware thing. So he has to worry about application logic, not on the messy details of data management, guys. Okay, the system itself is responsible for figuring out where to store the data and how to replicate it for fault tolerance and how to retrieve it efficiently. So this dramatically reduces complexities and allows developer to innovate faster. Correct, no? Am I right or wrong, guys? And what is the second point I'm explaining here? Easier to model data with a flexible schema. Guys, we saw the problem with fixed schema when dealing with semi-structured data. Big data system, particularly NoSQL databases, are designed for flexible schemas. Okay, see, look at here. You can see in this slide. So it is not necessary that every record has some set of attributes. Okay, so we have different models. Key value pair, different model. Document based, different model. Graph based, different model. So these are all designed to handle data that does not fit into a rigid table. A document based, see, let me take the example of document based. Okay, so it is perfect for storing JSON product record because it is designed to store and retrieve entire documents. So each with its own flexible set of attributes. So this gives developers the freedom to evolve their data model as the application evolves without the massive overhead of schema migration. And third point I've explained you here, if possible, treat data as immutable. So this is a profound shift in thinking. Guys, in traditional RDBMS, if you want to change a record, okay, you issue a command, right? That is called as update. Correct, no? And the old data is overwritten here. So in many big data systems, particularly those built for analytics, the philosophy is to treat data as immutable. So the meaning of this is, so it cannot be changed. So instead of updating a record, you keep adding timestamped version of the data values. That is what I have mentioned here. So if user's salary changes, you don't overwrite the old salary. You add a new record with a new salary and a new timestamp. So this is like a what logbook, guys. So this is how huge. See, what I would like to say is, so there is a what huge advantage of using this, guys. It makes much easier to what track the history of changes over a time. That is one advantage. And the second advantage is it avoid human errors by not destroying good copy. So if you accidentally make a mistake in an update, the old correct data is still there. So is it not interesting, guys? The concept of immutability is a cornerstone of many big data architecture. And it is our direct response to the need for data integrity and traceability at scale, actually. So to the sum it all up, guys, big data systems are designed to developer friendly by abstracting away the complexity of distributed system. They are flexible. Okay, they are allowing for what dynamic data models, and they are often built with immutability as a core principle to ensure data integrity and historical traceability. So hope everyone is understanding this. And moving forward, guys, you can see here. Okay, so application specific consistency model. This is the point I have mentioned here. Guys, we already touched upon this, right? This concept already we have touched upon. See, traditional RDBMS forced us to what? Forced us into what? Strong consistency model with ACID properties. But big data systems gives us options. Okay, so for a social media site, for example, a new comment might be what returned to one replica and it might take a few seconds to appear on all the others. Okay, the system allows you to make a choice. Okay, see, look at here. I have mentioned a keyword here. You can set a read preference option in MongoDB. So this is allowing you allow a reader to access replica that has not been updated yet. So this is a what trade-off that is perfectly acceptable for many applications, and it gives us a huge boost in performance and also scalability. Try to understand this. And guys, it is going to handle high data volume at very fast rate coming from variety of sources because immutable writes are faster with flexible consistency model. Okay, what is the meaning of this, guys? So this is the ultimate goal, right? And it is achieved because of the what characteristics we have discussed. The immutable principle where we just keep adding data versions with a timestamp and makes write incredibly fast. So we are not doing any heavy update here. We are just appending a new record. At the same time, so replica updates can be what handled in background. So which is much more efficient. So this allows us to handle that massive constant stream of data we saw from sources like social media, jet engines, and web clicks actually. Okay, so this is the what great time to introduce a real world examples, guys. Okay, so here I have mentioned real world example. Cassandra is a NoSQL database for write heavy workload and eventually consistency. So this is the database. I'm talking about Cassandra now. This is the database specifically designed for the problems we have been talking about. It is built from the ground up to the what? Up to handle massive distributed data set with fast writes. And it embraces eventually consistency as a what core principle. So this is just one of many tools we will be what exploring. Okay, but it is perfect example for system built to solve these big data challenges. Guys, see in this session, so we have gone a journey We started with the simple question. So what is big data? And we now arrived at more fundamental understanding of why we need these new kinds of system. So we have seen that the volume, variety, and velocity of modern data breaks traditional tools. And we have identified the key characteristic that the next generation of data systems must have. And automatic distribution, flexible schemas, and customizable consistency model, everything we have learned, guys. Correct, no? And moving forward, when I'm talking more about this characteristics of big data, so here I have mentioned very first point, built as distributed and incrementally scalable system. See, that also already we have discussed, right? So we talked about how sharding and RDBMS is a complex by using what manual process. Guys, big data systems are designed from the ground up to be distributed. Okay, you don't have to re-architect your applications every time your data grows. So you can simply add new nodes to scale. That's it. So this is the fundamental idea behind Hadoop cluster. So as your data grows, you add more commodity servers and the system automatically takes care of the distributed of data and the workload. This makes scaling a routine and increment task rather than massive expensive project. And I mentioned second point here, options to have cheaper long-term data retention. Remember, we talked about how expensive it is to store massive amount of data for a long time in the RDBMS. Guys, big data system solves this by giving us options. Correct? Already I've explained you, right? So where the trend might not need to be instantaneous. So we can tolerate more latency. So this allows us to store data on cheaper and long-term data retention. Okay, a perfect example for this is HDFS. So yes, I'm going to show you HDFS tool, guys. In lab session, I'm going to explain you HDFS. So it is a file system that runs on a cluster of cheap servers and is designed to store massive files reliably and cost effectively. So this is a game changer for businesses that needs to store and analyze years of historical data, guys. And what is the third point I mentioned here? Generalized programming model that work close to the data. Guys, so we have the example of Hadoop MapReduce concept. I will show you this Hadoop MapReduce concept, guys, and also I'm going to show you one program on Hadoop MapReduce. Then you will understand so how it is, how this general programming model is going to work with huge amount of data. Okay, guys, actually this tool directly run on the nodes where the data is stored. So this minimizes data movement over the network. So which is often the biggest bottleneck in a distributed system. The logic is sent to the data. The computations happens in parallel on all the machines and only the final results are aggregated here. So this I will explain you later, guys. Now I'm explaining you means you will not understand. So this is the concept behind MapReduce concept. So what I can summarize here, guys, big data systems are not just about handling more data. Correct? No, it is not only handling more data. So they are about fundamentally changing how we approach data management. They are built for horizontal scalability. Okay, they provide cost-effective storage for the long term, and they use new programming models to process data efficiently in place. Correct now, guys? Guys, this brings us to the end of the foundational concept. So we have covered a lot of ground today. So you should now have a solid understanding of the motivations of big data, the 3 V's of big data, and the limitations of traditional RDBMS, and the core characteristics of new distributed system that solve these problems. Okay, so next we have one more concept, guys, that I don't know whether I'm going to cover in today's session. So we have left with only 3 minutes. So here we have to talk about two more things, guys. So one is on architecture and another one is on locality of reference. Guys, if I start reading slides, then I can complete syllabus in a given time. But I'm taking too much of examples and explaining you because you have to become very strong in fundamentals. I don't want to compromise here, guys. Because of that reason, I'm taking too much of time to explain each and every concept in detail. Okay, so still we are in what? Session 1 concept. So maybe yes, in future. So somewhere we are going to get less slides. So there we can cover more data, more informations. So next class, I'm going to continue with all this architecture part and also. So we have left with two case studies, and locality of reference is also very, very important. So I will try to complete this by next session, guys. Or else, yes, guys. So we have to take one extra session to complete the syllabus. That we can think later. Yes, actually, yeah, very good question is asking by one of my friend. So how the data synchronization is happening when multiple DBs are used? See, again, so very good question from who is that? Minto Mono. Minto Mono, this is also the job of big data analytics. Okay, so your big data tool will take care of everything. So synchronization part is also taken care by big data tools. So as a developer, so as I told, you just concentrate on data, what you are passing to the system and what outcome you are getting. That's all. And think about your programming. So not about any working principle of your tools. Guys, automatically it will distribute the data. Automatically it will partition the data. Automatically it will replicate the data. Automatically it will compute the data. Okay. So finally, after computations, okay, after computations parallelly, so it is going to consolidate output at the end also. So only the thing is you have to give input and then you have to wait for the what output. That's it. So every synchronization, every coordination, every distribution will be what taken care by your big data systems. So that is the advantage of using big data system. Is this clear, Minto? Minto Mono. So anyway, Saturday you people are free, right? So if I planning to take one extra class, two extra classes means I can take on Saturday, right? No issues, right? Okay, thank you always. Because yes, so last class I have given only introduction. So this is the information we got from higher ops. Because August 2nd or August 1st was the last day to admissions. So that's why we have not started with the session. Okay. Saturday morning means what time? Saturday morning, I think you have one more class, right? So Saturday at what time you have regular class? Niklesh? So when do you have regular class on Saturday? 8:20 to 10:20, right? So after that, I will plan to take. So immediately, I'm not going to take extra class, guys. So let me complete some syllabus. Because yes, even I need extra classes to conduct laboratory concept also. So have you got any access to your lab? So have you got any access to your lab? No? Okay, not yet. So I will request with the higher ops to give a lab access. Okay, so yes, guys, I have to complete theoretical concept first. So once I'm starting with Hadoop concept, then you will be in a position to what? Write a program on HDFS. So right now I'm teaching you only theoretical concept, right? So this is not the right time to what? Teach your laboratory programs. Yes, that's all for today's sessions, guys. If you have any question on today's session, you can ask me. So this is the time to answer your questions. But please do inform to your friends, guys. So attendance is mandatory. So nowadays we have about AI tool. That AI tool is monitoring each and every student's attendance. So attendance is mandatory. So please do inform to your friends to what attend the classes. So if you have any questions on today's session, you can ask me, or else we can wind up the session. So before winding up, please give me some information, somewhat feedback on today's session, guys. So tell us the time from your side. Accordingly, we will manage for the extra class. Okay, no problem, Anu. Thank you. Thank you for your cooperation. Arup, sorry. So how was the session? Don't say thank you directly, guys. So I want you people to give your feedback, frank feedback. Yeah, Amit, I can understand, but yes, sometime so it is more disturbance. So when I start explaining your lab session, then I will open mic for each and everyone. Is it okay, Amit? Otherwise, I would have spent more time on questions only. Correct? No? Yeah, let me complete theoretical concept. After completion of this theoretical concept, so I will open the mic. Yes, give me one line feedback on today's session, guys. So any feedback is okay for me. Positive, negative, anything is okay for me. Thank you, Raj. Soumya, Jyoti, already have addressed this. No, textbook already it is given in handbooks. Okay, so you just go with the handbooks we have uploaded. That is enough. And my slides are very much enough. Yeah, big data is all around. 100% correct. Sir, any assignment, homework for the week before next Sunday? Right now, no. You just go with a few concepts about big data. Sir, can we have regular session on Saturday itself? Having 3 classes on Sunday, it is bit hectic. Priyanka, you discuss with higher ops. So right now, even I am handling 2 class on Sunday. Okay, 2 classes on Saturday. So even I have to think about this, right? So I will check with this. Yes, no questions, guys. Yes, thank you all, guys. Thank you for attending this session. So I know this is what evening session. Since it is evening session, so 5:50 to 7:50. Yes, I am making my means. I'm doing my best to engage you people, guys. So I'm giving more informations to understand each and every concept clearly. Okay. So I'm not thinking this is the evening session. I think in evening you will be having more fresh mind, right? So yes. So time is not a matter for us. Already we have uploaded slides on your portal, guys, on your Taxila. You just go and download the slides. Annotated slides are shared. And also I'm sharing all these slides in Microsoft Team also. Okay, you can download slides from Microsoft Team or you can use Taxila to download your data, to download your annotated PPTs. Okay, so Mohnish Saini is asking about this. Okay, let me show you, Mohnish. So here I've clearly given each and every concept. So textbook I have explained, and these are all the lab programs we are going to discuss. Okay, these are all lab programs we are going to discuss, guys. HDFS operations, Hadoop MapReduce pipelines, BigQuery, HBase, Hive, MongoDB, Neo4j, one example we have, and AWS S3 buckets, we have one example. Spark and machine learning, we have one more example. Okay, this is about lab session. These are all theoretical concept. Session 1 to session 16. So we have mentioned all the topics. So we are starting with introducing big data concept along with the data locality concept. Then we are jumping to parallel distributed processing. And one more thing you can observe here, this is only textbook. Objective is also mentioned in the very first slide. And examinations. Okay, you have EC1. So under EC1, you have two components. One is quest and second one is assignment or lab assignment. So both are online, guys. So for this, we have reserved 30% of your marks. Okay. So under 30%, 10% is for your quiz and 20% is for your assignment. So we have given 1 week of time we are going to give for quizzes, and 7 to 10 days of time we are going to give for assignment or lab assignments. Okay. And even we have mentioned date here. So in your handout, we have mentioned dates also. And this is EC1 and EC2. So we have midsem examination. So this is closed book examination. And the weightage for this is 30%. And duration 2 hours. And date is also mentioned here. Okay. And next to that, we have one more component that is called as EC3. It is a comprehensive exam and it is open book exam. And whatever the material you have to carry, everything we have mentioned in a Taxila. You just go and download it. Otherwise, it is given in handouts. Okay, the weightage for this is 40% and examination duration is 2.5 hours. Okay, so this is about evaluation metrics actually. And syllabus and everything we have mentioned here. For midterm, so we are going to give contact session 1 to 8 and comprehensive exam. So we are going to give all 16 sessions concept actually. So closed book means what you have to carry. Open book means what you have to carry. Everything I've mentioned here. You just go through this. And this is a website address. You just go and click on this website. See, you will get all the informations here. Okay. So my request is always means regularly look at announcements, deadlines, and course updates. Okay. And contact session, attend online lectures as per the what schedule provided on the eLearn portal. Okay. So makeup exam information is given in your portal. So only for the genuine reasons. So they are going to provide you makeup exams. So for that, you have to apply in the website. So this is about the entire course. Is this okay, Saini? Saini, have you understood quickly? I've explained you this. You just go through the handout. Everything is clearly mentioned. So have you downloaded handout, Saini? Or else first 2 hours I have taken on the same thing. You just go with the first session recording. I have explained each and everything in detail. So is it possible to upload the previous year's question paper? It is already uploaded. So it is already uploaded in your Taxila. Okay, in Tuxila, you have, one second, I will show you guys. Yeah. Guys, you just look at here. In Tuxila, you have past question papers. You click on this, so it will show you old question paper. You can download old question paper and you can look at that. Ajib, is this clear? Anything else you want to ask, guys? So one question, when we are uploading the data on S3, there is a limitations of 5 GB for a single file. So we can use multi-part upload for the data more than 5 GB plus file. But how the algorithm breaks the file into parts and how the algorithm manages these parts at the time of upload and how it is being associated with after completion. This is what you are going to learn throughout the big data concept. Okay, see, that's why we are all using cloud, right? In cloud, we'll be not having single resource, is it? So once we have 5 GB plus data means automatically it will take the data into different space and it is going to store. That is the job of cloud software actually. It will go and search each and every spaces, each and every what systems or each and every hard disk. So once there is a space, then it is going to occupy. Then it is going to what place the data. Ishpande. That is called as distributed concept. Yeah, in upcoming days, you will understand each and everything, guys. No need to worry. And as a programmer, we are not going to worry about that. We'll never ever think how it is what distributing data in our different systems, different hard disk spaces. So in case of RDBMS, we have to think about that. But here, no. That is one of the advantages of using big data tools. Ishpande, is this clear? Any other questions? Not for today. Okay, Sini. Sini, you better go with the recordings. Okay, guys. Is there any WhatsApp group for us? No, actually, we are not going to encourage WhatsApp groups. So as a student, you can create your own groups. Suppose you want to discuss anything with us, means you just go with discussion forum. See, I will show you the discussion forum here. Yes, you have a what separate discussion forum here. You place your question on this general discussion forum. Once you are uploading your discussion on this discussion forum, so you'll get notification. So immediately we will what communicate with you people. Yeah, you can drop anytime. Yeah. See you next week. Okay, guys. So no questions means we can wind up today's session. Okay, let me stop recording.